So differential equations that we're solving for today are pretty much their slopes. And we want to go backwards and solve for the original equation. And it's really another way of thinking of it as an antiderivative. I'm trying to find the original equation given the slope. And we've done that traditionally with the same, let's say f prime of x is equal to x squared dx. And we went back and said, well, the f value is going to be x squared over 3. Sorry, n plus 1 over n plus 1. That's terrible. Plus c. And then we're given some x and y, and we can solve for that c value. Now, these types of problems are pretty much the same, essentially the same thing as that, except we might need a couple new tools since we did learn some new integrals to work on these types of problems. So let's do the first one here. And today we're doing specifically natural log and exponentials. So natural logs and exponentials. So here we go. Our first problem is going to be a good example of this, is dy over dx is equal to 6x squared y. Now, as you can tell, x's and y's are splendid on the same side. This might not be always the case, but this is the case here. So we want to separate our y's and our x's. So this y has to go left, and this x has to go to the right. So dy over y is equal to 6x squared dx. Now, just to repeat how I did that, the opposite of multiply by y is divide by y, so we would divide y to both sides. And the opposite of divide by dx is we would multiply dx to both sides. That's why dx is on top and y is on the denominator. Now we then take the integral of both sides separately. So integral. So you can imagine the right side doesn't exist, the left side doesn't exist. What is the integral of 1 over y? And we've talked about that before. It's the same as 1 over x is natural log. Absolute value of y is equal to, the right side 6x squared is really 6x cubed over 3. We can save ourselves some time rewriting it as 2x cubed plus c. Double check if you want. The derivative of 2x cubed is bring down the 3 is 6x squared. Okay, so really it's just us taking two separate integrals. Now, they want to solve for y by itself. So let's go ahead. A method is to go ahead and solve for y by itself. So to get y by itself, you need to get rid of that natural log and the absolute value. So what we're going to do here is we're going to go ahead and e both sides, because exponentials get rid of absolute gets rid of natural logs, and we're left with the absolute value of y is equal to e to the 2x cubed plus c, where these are all in the exponent. Now here's the next move, and this is just a move that you're taught. It's really back from algebra 1. We're going to split that exponent to become a multiplication. Here's an example. If I write 3 x plus 2, this can be written as, if I'm adding exponents, I'm really multiplying the powers. Using numbers, if I said this is 3, 5 plus 2 is really 3 to the 5th times 3 to the 2nd. Okay, and this is an important trick. You have to use this trick. It's super important because I'm going to rewrite this as absolute value of y is equal to e to the c times e to the 2x cubed. Now this is a skill that you practice. You have to practice so you can be fast at it. Knowing that the plus sign is really multiplying powers, I kicked it to the front. And we're going to call that just some c value. I'm going to call that c1. Because e to the c power is really just some constant. Now, there are a couple ways of doing this next part here. I'm going to tell you the easy way, the non-thinking way. On my YouTube video, I show a slightly different way of thinking about it, algebra way approach. But we're going to say right now that the absolute value just goes away. Why does it go away? Well, absolute values, we traded them. If you remember from algebra 1, darn it, I should talk about it then, fine. Absolute value of y, if I said is equal to 4, what are my possibilities for y? This could be 4 or negative 4. Both those answers are true. Now, which one do we use? I don't want to end up writing two versions here, but the idea is that if I write 4 or negative 4, those could be answers. But instead, if you were taught this before, to rewrite all the possibilities, what we do is we say there's two equations now. Y is equal to 4, and y is equal to negative 4. When do we use either? Well, if y was negative, we would be using this guy. But let me show you guys a different way of thinking about it. I'm going to give the negative to this guy. If y was negative 4, doesn't the negative negative cancel out to become positive? And absolute value signs makes everything positive. If it's positive already, no big deal. We can pretend the absolute value sign never existed. But if it turned out the y value or the variable was a negative, you just have to give it another negative. And if I give it another negative, it forces it to be the positive that we wanted. So what we're doing here is we're saying, hey, I get it's just a difference between a sign. And you know what? This constant here will take care of that. That could be a positive or a negative. So what we do is we just clean it up and say this. Y is equal to C1 e to the 2x cubed. So I could include a negative here, and actually we should. Looking at the problem here, my y value, this is the x, and this is the y. The x value that we were going to plug in was going to be negative. See, it's going to be negative here. So we should have used this negative version over here, but we're not. We're just going to say y is equal to c1e to the x cubed. Where did the negative go? The negative is going to be reflected in our c1 value here. So now that we solve for y, we're going to plug in our x and y to find our c value. And this is very similar to when you guys were solving for line equations from Algebra 1. Y equals mx plus b. Y is equal to mx plus b. If you plug in your x, your m, and your y, you then could solve for b. Remember, we would solve for b by itself. So we're going to solve for c this time, plugging x, y in. So if x, let's rewrite that up here, it's negative 3, and my y value is negative 2 over 54. You might say, those are crazy numbers. It's fine. We're just going to plug it in. So y and x, plugging in here and here. So y is negative 2 over 5 to the, did I say 5? No, that's like 3, right? Oh, e. It's e. I miswrote that. E to the 54. And e to the 54 is equal to c1, which we don't know yet. We're going to go ahead and go back and solve for that, is e to the 2 negative 3 cubed. Do the math on the side. Negative 3 cubed is negative 27. And negative 27 times 2 is negative 54. So this problem, to rewrite, I'm sorry, running out of space here, is negative 2 over e to the 54 is equal to c1, 1 over e to the 54. And why did I write down the denominator? Because negative exponents allow me to flip the fraction. So what does c1 have to be? Well, c1, well, let's go ahead and just do the algebra one. If I multiply both sides by the e to the 54 to solve for c, c1 is equal to negative 2. Now, let's see the answer gave us. What happens is if you look what they did here, they did it actually the other way, which is fine. When we rewrite the equation, y is equal to c1 is negative 2, e to the 2x cubed. And this is our answer for a particular solution. Now, to verify that this was the actual answer, we could take the derivative, and that eventual derivative will give us this value here. We could follow up with plugging in the x and y. If I plug in x is negative 3, let's go try it. If I plug in x is negative 3, we said that negative 3 cubed is negative 27. 27 times 2 is 54. Negative 2 over e to the 54, and that is our y answer. So all this stuff here is really algebra 2. The biggest catch that you need to be able to do is this step here. This is actually the biggest step. This is the second biggest step. What do you do with absolute value sign? Get rid of it. Let's call that C1. Now, there is a logical way of rewriting that and carrying the negative over, which is how the answer is presented in this worksheet. But oftentimes it's flip-flop between both ways. So that's why you just got to pick one that you're used to and stick with that. On the AP exam, the answer that they are going to be satisfied with is this guy here. That's the solution for that particular point. We're going to do one more problem. Okay, and let's do, I'm just going to pick a random, let's pick like some ugly one like number 4. I haven't even tried it. Okay, let's try number 4. This looks pretty messy. dy over dx is equal to, we're going to factor out what we have in common. I see an x. I'll see a y, I'm sorry. A y, we're left with 2x plus x squared. As you can tell, we can separate the variables. Y is on one side, x is on the other. dy over y is equal to 2x plus x squared dx. Hey, now that we separated variables, we can take the integral. That's natural log of y is equal to, let's go ahead and do the power rule here. And I'm going to write this in the front. X cubed over 3 plus 2x squared over 2. And we can say those 2's divide out. And we're going to write plus c. All right. So from this point, we're going to go ahead and solve for y. So we have to get rid of that natural log. So let's go ahead and e both sides. E both sides. And we're left with absolute value of y is equal to e to the x cubed over 3 plus x squared plus c. What do we see about what we're going to do with this plus c here? When we write that as e to the c times e to the x cubed over 3 plus x squared. And we're going to call it e to the c just c1, rewriting that as some constant. So absolute value of y is equal to c1 e to the x cubed over 3 plus x squared. So because we have that c1 there, this could be plus or minus. It could swing with the punches. You dodge with the punches, flow with punches. Nah, I forgot it. So this can just be written as y. Cool thing is we can just call that y, and c1 can be positive or negative later. c1 e to the x cubed over 3 plus x squared. Now that we have this in a nice form, we can go back and say, hey, what would c be? Plugging in our x value and our y value. See, our x is going to be 0, and our y is going to be 2. So if we go ahead and say, whoops, darn it, where'd it go? Uh-oh. Darn it, it died. Okay. We were at this last point. Darn it. We were at the point where it said y is equal to c1 e to the x squared, no, x cubed over 3 plus 2x. Okay, we're at that point there. We're going to plug in 0, 2, where that's my x and my y value. I got that from here. So y is 2 equals to c1 e to the 0 over 3 plus 2 times 0, which is just 0. What's e to the 0? That's going to be just 1. And I'm not going to write that. So we know c1 will be a positive 2. Rewriting the function, y is equal to 2 e to the x cubed over 3 plus 2x. And if I want to verify that, if I plug in 0 here and 2 here, the answer gives us y is equal to 2, which gives us our correct answer here. I'm going to go check the answer in number 4. So if I plug it in the 2, that's the answer that we got. Okay. So these problems are quite daunting because they actually have a lot of steps. But I guarantee if you spend 10 minutes on this, doing the same problems over again, you'll actually see the gimmick. And the gimmicks are, as I mentioned before, changing e to the x plus c, whatever it may be, to e to the c plus e to, no, it's not plus, times e to the x, taking that c value to call it a constant, and then getting rid of the absolute value to just be a regular value. And those are the gimmicks for all these types of exponential problems where you have natural log.